Let's work on question number 8, please.
Question number 8. Should put it. And you done 8? Go to 9. 9. Yeah.
Just come in, can you do question 8, please? Question 8.
Can you guys do question 8, please? I'll give you like a couple of more minutes, right? And then I'll show you how to do it if you haven't done it. Okay, so take 2 more minutes and see if you can do question number 8. Alright guys, so let me show you how, if you haven't done it, I know some of you have already done it. So let me show you how to do it. This is question number 8 on the tutorial sheet. So it's basically, you have a random sample from a population with 0 mean and variance sigma squared. And you got this as a possible estimator for sigma squared. Right? And the first part is to find k so that this estimator is unbiased for sigma squared. Now remember, an unbiased estimator is an estimator that has 0 bias. So what you need to do is to find the bias of this, right? Which I'm sure I said this many times. A bias is defined as the expectation of the estimator minus the parameter that you're trying to estimate, right? So this is going to be this. Now k is a constant, so you can pull the expectation inside. So this would be the sum, k times the sum of the expectation of xi squared. Okay, you guys with me? Right, now what I'm going to do is a small trick. I'm going to write this guy here as you see why I'm doing this? You see why I'm doing this? Because remember, this guy here, what do you know this? What do you know about this? This is the variance of xi, right? And we are told that the population variance is sigma squared. So this guy here is equal to sigma squared. Yeah? And the expectation of xi is the population mean, and we are told that the population mean is equal to 0. So this is equal to 0, right? So what you have is k times the sum of sigma squared minus sigma squared. And so this is k times the sum of this sigma squared is a constant with respect to I, so it's simply n sigma squared. And this is 0 if and only if k is equal to 1 over n. So that's the answer to the first part of question number 8. Is that all clear to you or not? Hello guys, any questions? Is this clear to all of you? Right, the second part is asking you if xi are from normal 0 sigma squared, what is the sampling distribution of the estimator, right? So what it's asking you is the following. So this is part 2, question 8, part 2. So we are assuming that x1 to xn are IID from a normal distribution with parameter 0 and sigma squared. And we are looking at the estimator we are looking at this estimator, right? Okay, and the question is, what is the sampling distribution of this estimator? Now, in order to answer this question, All right, before I answer the question, it's something that we talked about in the class. You should do remember, like, what I'm going to do is, I'm going to multiply by sigma squared, which is the population variance, and divide by sigma squared. And you will see why I'm doing this in a sec. You will see why I'm doing this. You should go back to the website, the course website. I don't know how to get this on, but let me see if it works. Come on. All right, you should go to the course website. We talked about sampling distribution. This is big 3, right? And if you look under the chi-square distribution, one of the properties we talked about is this one, property number 6, which says that if you have IID normal with these parameters, right, then this guy here has a chi-square distribution with n degree of freedom. Now, in this case, in our question here, the mean is 0, right? In other words, the mu is 0, right? So this guy here becomes, the thing on the left-hand side is precisely what I wrote down. Do you see that or not? Yeah? The thing on the left-hand side is what I had on the slide, all right? So this has a chi-square distribution with n degree of freedom, right? So now let me go back to the visualizer. Hopefully this works. Okay, it works now, right? So what I'm saying is that using property 6, which we left property number 6, right? Using property number 6, we can say that this is the sampling distribution of sigma f squared, right? All right, so that completes question 8. Is that okay with all of you or no? No, guys, you okay? Can you do the next one, please? Question 9. If it's okay. If it's not okay, just feel free to give a shot. Okay, let's ask question number 9, please. The first part, you just remember 1 over n, p to the 1 over n. So the estimate will be x 1 over n minus the sum. And the second part is to show that the standard distribution of this number. That's why we use properties. That's the one we use property 6. Property 6 on the class of 2. Go back to show you what I'll give you a few more minutes to do question number 9, and then I'll show you. Okay. Okay, guys, let me show you how to do question 9 now. Right, question. So you got a random sample from a uniform. So you have x1 to xn IID uniform 0 theta. And you got this estimator for theta, which is k times the sample mean x bar. I mean, you can ignore the subscript, it's okay. X bar denotes the sample mean, okay? K is a constant. So the first part is we want to find k so that this estimate is unbiased. So it's the same as the previous question we did. So what we need to do is we need to find the bias and set that to 0 and see what k is, okay? So the bias is this. So this is the expectation of k times x bar minus theta. K is a constant, so you pull it outside. Now x bar we know is the sample mean, so you can write it like 1 over n times the sum of the data. Okay. Now take the expectation again inside, so you get this. Okay, now do you guys remember what's the expected value? Now you have a uniform 0 theta, so what's the expectation? Xi is uniform 0 theta. So the expected value is theta over 2, yeah? So this is going to be k over n Alright, now theta over 2 is a constant, so the sum of a constant is n times the constant, so this is what you get. The n and the n cancels, so this is 0 if and only if k is equal to 2. So what this implies is that theta hat defined by 2 times the sample mean is an unbiased estimator of theta. Okay, so that's the first. The second part is find the variance of theta hat. Now, I'm sure you guys know how to do it. This is okay, by the way. Any questions on this, guys? Give a shout, feel free. All of you okay with this? Alright, now to find the variance of, so part 2 is to find the variance of, so we want to find the variance of theta hat, which is variance of 2 times the sample mean. Now taking the 2 outside, it becomes a 4. So 4 times the variance of x bar, which is 4 times the variance of Now taking the n outside, it becomes n squared. So this becomes the sum of the variance of xr. Now once again, I'm sure you do remember what's the variance of a uniform variable. 0 theta is b minus a squared divided by 12, which is what? In this case it will be theta squared divided by 12, right? So this is yes, and this is a constant with respect to n, so what you have is this, And if you simplify this, you get theta squared divided by 3n. And this clearly goes to 0 as n goes to infinity. So what this means is that theta hat is a consistent estimator of theta. Because remember, the MSC in this case, the mean squared error is the same as the variance because the bias is 0. So that means in this case theta hat has both the good properties, that is unbiased and is also consistent, right? You guys okay with this? Or not okay? If it's not okay, feel free to say so. Yeah? Are you sure all of you are okay with this? Yeah?
Can you go
Yeah.
back to the previous page just for a second?
Previous page?
Yes.
Where is it? Where did I put it? Can't remember where I put it. Where is it? I see it. Yeah. Yes. What's up with this? Any other questions on this question number 9? Are you guys okay? You sure you're okay? If you have no question, can you do the next one, please? Question 10.
What do you like expectation of one of those
That's the constant, yeah. The 1 plus 2 is the constant.
Yes.
So the expectation is just a constant.
Alright, would that start on this machine? Would that be like n of n plus 2 in that case?
It's just on the one.
Oh, one of them. Okay.
Yeah.
All right, guys. So hope you got. Let's see how we can do question 10. Okay. So you have. This is question number 10. You have a random sample from a binomial so the size is n, which is IID from a binomial with parameters m and p, it's easy to get confused. It's easy to get n and m are two different things, right? Easy to get them confused. So you have to be careful. So the estimator is p hat equals to x bar. X bar is with respect to n, not m, right? This is the estimator for p, and we want to find the bias and the variance. So let's try the bias first. This is the definition of bias. I'm sure all of you know this. So this is the expectation of x bar plus 1 divided by n plus 2, take away p. Now n plus 2 is a constant, so you can pull that outside. Right? Now let me, what you have here is the expectation of x bar, right, plus 1 outside. Right, because one is a constant. One is a constant, so the expectation of constant is itself, right? Now to find the expectation of x bar, you just need to put in the, I'm doing this slowly, but I could have done it in one step, but I'm just doing it slowly for you guys, but I just want you to follow this clearly, because it's easy to get confused, because now the n here is a constant, so you can pull that outside, so this is n. Right, now then you have the sum of the expectation of xi, right, plus 1 outside minus p. Now I'm sure all of you know the expectation of a binomial. Now remember, the binomial is with parameters m and p, right? So the expectation is mp, right? So this is gonna be m times p like this, yeah? Now mp is a constant with respect to I, so the sum is gonna be n times mp. Yeah? You follow me? Yeah, so the two n's cancel, so the final answer is mp plus 1 divided by n plus 2 minus p. So this is the bias of it, right? I'm sure you got this right. You have to be a little careful with the n and the m, because they are two different things. M is the parameter for the binomial, where n is the sample size, right? So don't get them confused, right? So that's the bias. Now the variance of x p hat is gonna be the variance of, this is where what you did in probability 1 comes in, right? This is the variance of x bar divided by n plus 2 plus 1 over n plus 2. Now this guy is a constant, right? Remember, adding a constant does not change the variance. You should know that from probability 1, right? So this is the variance of x bar divided by n plus 2. Now n plus 2 is the constant, so if you take it outside, it becomes 1 over n plus 2 squared times the variance of x bar. Yeah? You with me? So this is 1 over n plus 2 squared times the variance of this. Yeah. Now are you guys okay? All of you following me? Give me a shout. Okay. If you take this n outside, it becomes a square. Now, I'm sure all of you know that the variance of a binomial is np times 1 minus p, right? So that's an m, not an n, okay? So you have to be, so what you have here is np times 1 minus p, right? Once again, this is a constant with respect to I, so you're getting there nearly. This is gonna be n m p times 1 minus p, and if you simplify this, you will get the final answer, which is n plus 2 squared times n. Alright, so this is the variance of the estimator, and it's also asking you, alright, as n approaches 0, this goes to 0, clearly, right? But the bias, this is the bias, this approaches minus p as n approaches infinity. So what you can say is that it's not an unbiased estimator, and it's also not consistent, because remember, when you work out the MSC is the variance plus the square of the bias. So this estimator is not good in both areas. That is, it's not biased. It's not unbiased, and it's also not consistent. Right? You follow me or no? The reason it's not consistent because although the variance goes to 0, the MSC will not, because remember, the MSC is the variance plus the square of the bias, and clearly the bias does not go to 0, right? Okay, bias goes to minus p. Okay, guys, so we have only a couple of minutes left. Can you do question 7, please? I don't know whether or any questions on the stuff that we did today, you can ask me now. Correction, yeah, but we don't need yet. Yeah, we didn't do it yet. Because we didn't do continuous correction, so you don't need to answer it. Yeah, you don't need to answer this question because we did not cover continuous correction. Just ignore this question. Yeah. How are you guys doing? Okay. You will respond. Guys, the full solutions to the tutorial sheet, including the video solution, the handwritten solution, the typed solution, are all on the course website. So please check them out. I'm sorry, I'm able to do only 3 questions per tutorial because of the time, but you can see the video solution which contains the solutions to all the questions. Right? All the questions. So see you guys later. Take care. Any questions, just feel free to contact me 24/7, okay? works. You can keep it. You can keep it.
Yes. For the previous summation, I used become more standard normal distribution and calculate the probability I gave you.
No, you need to use the chi-square. What is the probability that, yeah, you need to use the chi-square principle. Remember, did you look at the solution? This is the table.
Yeah. This is solution.
Yeah, you need to use the chi-square properly, which I'll show you here. Here, you need to use this property here. You need to use this property to do question 7.
Is this notation equal? Denoted equal?
Yeah, it means distributed as. This notation means distributed as.
Okay, can I denote it equal?
Yeah, you can denote it equal, yeah.
So, how to get this? I don't quite understand.
Did you, what I'm saying here, you should look at the S squared is the sample variance, right?
Yeah.
And according to this property, this has the chi-squared with 9 degrees of freedom.
Oh,
right?
yeah.
Because you have to multiply, you should multiply this by 9, then this 1 over 9 disappears, right?
Yeah.
And divide by 36. 36 is sigma squared. Yeah, 36. So you should take this to the left-hand side. This whole thing has chi-squared in -1, which is 9 in this case.
Yeah.
So n is 10, so at -1 is 9.
Yeah.
So then you use this property, which is this, to calculate the probability that S squared is between 25 and 60.
And use the tables of the.
Yeah. Use the table for the chi-square distribution.
But why we can use this method to like use the normal? Yeah.
You can't use the normal because the normal is only for standard normal. Here, the question is talking about the sample variance, which is the question is talking about the sample variance. So you have to use this property here. By the way, if you want a more detailed solution, you can, just a minute, give me a sec. A more detailed solution, you should go to the handwritten solution, which is this one. This is more detailed than what is in the type solution. So you should go to question 7. Question 7 is this one here. It gives you more detailed solution of the probability that the sample variance is between 25 and 60. So just look at this one. I think this is more detailed than the type solution, which is this. This is the typed and this is the handwritten solution. Okay.
And I have final questions. Is that the unbiased one means the
Unbiased.
unbiased.
Yeah.
So how do we choose the unbiased or biased?
Normally you choose the unbiased version, not the biased version.
If
So like in this question, you'll always choose unbiased version.
Yeah, if the question said bias, you use over 1, and if not say anything, use
We use
Yeah,
unbiased.
that's right.
Okay,
Yeah.
thank you very much.
Thank you. Yeah, pleasure. See you guys.